Hello all. In today's session, let us start the next topic of Unit 3, Transfer Learning, which is one of the most important technique used in deep neural networks in building a vision system. These are the subtopics which we will be covering in Transfer Learning. Humans possesses an extraordinary ability to transfer knowledge. When humans are faced with new challenges or new problems, they try to dig past experiences and apply relevant expertise to resolve those challenges and problems. For example, how humans perform transferring of knowledge is, look into the figure here. If you know how to ride a bicycle and want to learn to ride a motorbike, your experience with bicycle will help you to handle the task in learning a motorbike, the tasks like balancing and steering, which will make the learning process smoother and even faster. In the second example, if you know how to play a violin, this experience can be used or knowledge of playing a violin can be transferred in learning how to play a piano. This is what transferring of knowledge in humans is. Similarly, a third example, if you have good knowledge of mathematics and statistics, that knowledge can be used in learning of machine learning models. That is, I am transferring the knowledge what already is existing in humans. This human learning approach was the inspiration for the development of transfer learning in machine learning models. So, transfer learning is essentially a technique where knowledge gained from training a model on one task or domain is utilized to improve the performance of the model on a different task or domain. It's, however, worth noting that this approach proves beneficial when the second task shares similarities with the first task, as you have seen in the previous slide example, where riding a bicycle is similar with riding a motorbike, or when limited data is available for the second task. To understand how transfer learning works, let us look into the figure. This figure explains the concept of transfer learning, where we have a source dataset and target dataset. Let us start with the source dataset. It contains of images of musicians playing different instruments. A CNN is used here. A CNN is trained with all the images. CNN has convolutional layers and dense layers. Convolutional layers extract features from the images. Dense layers processes these features and classify the input images into different instrument categories. Once the network is trained on the source dataset, this network convolutional layer which extracted the features has learned all the features of the images like patterns, shapes, edges, texture, etc. This network, the trained network or a pre-trained network, can be transferred to a new task in the target domain. So in transfer learning, I am transferring the knowledge from a pre-trained model to solve a task of a target dataset, and both have source dataset and target dataset may or may not have similarities. That scenario is different. We will discuss that later. In transfer learning, the convolutional layers which got trained with all the features of source dataset are freezed, and that is their weights and biases, that is their weights, updated weights and biases which got updated during the training on source dataset will not be updated here when training on a new target dataset. That is the reason why we will be freezing the convolutional layers. These updated and weights and biases are nothing but what? Features what are obtained from the source. These features will be preserved by freezing the convolutional layers. The new dataset contains what? Images of people playing guitars of different models. This is a different task than the source dataset, and the goal here is to classify these guitars. The frozen convolutional layer extract features from the new images, while the new classifier learns to classify them based on these features. Once the model is trained, it will be able to classify the images in the target dataset. So the model which is already been trained will be used here to classify the images of our target dataset. This is another figure which shows how transfer learning works, where we have a pre-trained model, the model which is already trained from one dataset and will be used for training the second dataset. The idea of transfer learning is straightforward. First, we train a deep neural network on a very large amount of data. During the training process, the network extracts large number of useful features that can be used to detect objects in this dataset. We then transfer these extracted features, also called as feature maps, to a new network and train this new network on our new dataset to solve a different problem. This is what transfer learning generally is. But why would we want to use transfer learning? Why don't we just train our neural network directly on our new dataset to solve our problem? To answer these two questions, we first need to know the main problems that transfer learning solves. That is, introducing transfer learning in deep neural network solves these two problems. The first problem is data problem. As deep neural networks are data hungry, that is, they rely on huge amount of labeled data to achieve good performance. So training a network from scratch requires a lot of data in order to get good results, which is not feasible in most of the cases and is also time taking process. Coming to the second problem which will be solved by this transfer learning is computation problem. Even if you are able to acquire hundreds of thousands of images for the problem, it is computationally very expensive to train those millions of images, because doing so usually requires days or even weeks of training in multiple GPUs. Coming to the definition of transfer learning is transfer of knowledge. What kind of knowledge we are talking about? As we are talking about images, we will talk about feature maps that the network has acquired from one task where we have a large amount of data to a new task where data is not abundantly available. It is generally used where a neural network model is first trained on a problem similar to the problem that is being solved. One or more layers from the trained model are then used in a new model trained on the problem of interest. This is the definition given by a scientist called as Jessen and his team in a paper they have published in 2014. Now let us just directly jump into an example which will give you a clear intuition how transfer learning generally works. Suppose we want to train a model that classifies dog and cat images, and we have only two classes, dogs and cats. We have only two labels here. So we need to we may have two options here. We need to collect hundreds of thousands of images for each class, label them and train our network from scratch. The second option is to use transfer knowledge from another pre-trained network. So let us talk about the second option, that is transferring knowledge from another pre-trained network. So to make use of this second option, we first have to select the dataset which is suits our dataset or suits our problem. So what is our problem? Classification of dogs and cats, images of dogs and cats. So we need to select a dataset which is similar to the task what we are given with. So let us consider ImageNet dataset which has lot of dogs and cat images. Next thing is we need to select a network which got trained with this dataset. And what kind of network we have studied in the previous sessions, that is the architectures are VGGNet, GoogleNet, ResNet and so on. These were the CNN architectures which got trained with ImageNet dataset. So we have selected ImageNet dataset here, which is similar to the dataset what we are planning to use. The second thing is we will be using a network which got trained with this ImageNet dataset. And in this example, let us consider VGG16 as our pre-trained model. That is, VGG16 got trained with ImageNet dataset, and that VGG16 we will be using it to classify the given image as dogs or cats. So to adapt the VGG16 network, we will be first step is downloading it with the pre-trained weights, remove the classifier part and add our own classifier, and then retrain the new network. This is called using a pre-trained network as a feature extractor. So you can see here, as I am using VGG16 for transfer learning, 13 convolutional layers you have and 3 dense layers. These convolutional layers which has extracted features, that is which has learned all the general features of ImageNet dataset, will be freezed. You can see here I have 13 convolutional layers here. These 3 dense layers will be removed and add a softmax layer with 2 units, as our classification task has 2 labels, dogs and cats. So for that, what do we do? In Keras, we have different steps. First, we will be importing VGG16 from Keras, and that initialized VGG16 is stored in a variable called as baseline model. And this is the syntax where I will be using weights is equal to ImageNet, where this model will load pre-trained weights from the ImageNet, include top is equal to false. It will exclude all the dense layers, that is 3 dense layers which are present in VGG16 will be excluded because we will be adding our own classifier here. And input image is of this shape. And this is the model summary. This is what we get when we print the model summary where VGG16 architecture is being implemented. You can see here all 13 layers of convolutional layers are being used. The 3 fully connected layers are removed. So till here you will have 13 convolutional layers, and the total parameters are 14 million, and all that parameters are trainable parameters. Trainable parameters in the sense we will train those parameters with our new dataset. But as transfer learning is concerned, we will not train the model what we are using, because it already got trained with all the features of ImageNet dataset. So we would like to make this trainable parameters as 0. For that, what do we do is we freeze all the convolutional layers. So when we freeze, we have this command to freeze. For layer in base model dot layers, layer dot trainable is equal to false, and this is the summary. This will print the summary. You can see here the trainable parameters got reduced to 0. That is, all the 13 convolutional layers are now freezed. The features that they have extracted from the ImageNet will be used in classifying our dataset for classifying images of dogs and cats. Fourth step is add our own classification layer. So we will import dense and flatten layer from Keras, import model, and here it will retrieve, this command line will retrieve the last layer of the convolutional layer. You can see here, this is my last layer, block 5 pool, that will be retrieved and will be stored in a variable called as last layer. This saves the output of the last layer as input to the next layer, and we will flatten it and make use of dense layer with 2 units, and activation function used here is softmax. So these 3 fully connected layers are removed and added a softmax layer with 2 units. And the last step is building a new model that takes the input of base model as its input and the output of the last softmax layer as an output. So you can see here, this is the model summary where it will take the input, base model input as the new input, and output will be stored in X here. And you can see here the trainable parameters are 50,000, whereas non-trainable parameters are around 14 million. Training the new model is faster than training the network from scratch. So we can look into this, like the trainable parameters in this model are 50,000 here compared to the number of non-trainable parameters which are 14 million. Though these non-trainable parameters are already trained on a large dataset, that is ImageNet dataset, and we freeze them to use the extracted features in our problem. With this new model, we don't have to train the entire VGGNet from scratch because we only have to deal with the newly added softmax layer. Now, how this transfer learning works? So far, we have learned what transfer learning technique is, the main problem it solves, and we also saw an example of how to take a pre-trained network that was trained on ImageNet and transfer its learning to our specific task. Now let us see how transfer learning works. So the following quick questions are reminders to know what transfer learning is. The first is, what is really being learned by the network during training? Feature maps. How are these features learned during the backpropagation process? What is the relation between features and weights? Features are obtained by passing the weights filters onto the input image. And the last question is, what is really being transferred from one network to another? To transfer features, we download the optimized weights of the pre-trained network. These weights are then reused as the starting point for the training process and retrained to adapt to the new problem. So let us understand what we mean when we say pre-trained network. When we are training a convolutional neural network, the network extracts features from an image in the form of feature maps, outputs of each layer in a neural network after applying the weight filter. These feature maps are nothing but what? Outputs of each layer in a neural network after applying the weight filters. So this is what generally transfer learning is and how it generally works. Continuation of this we will do it in the next session. Thank you all.